Okay then, so in this video, I'm going to be looking at an entropy change calculation question, but this time it involves a graph, okay? So I haven't done one of these videos on my channel yet where we have to utilize the Gibbs free energy change calculation, plot some data on a graph, and then be able to manipulate that in order to calculate our entropy change, okay? So this is from an AQA past paper if you want to check it out yourself. It was from A-Level Paper 3, June 2017, all right? Look it up, check it out, attempt it yourself, see where you go wrong, learn from your mistakes, okay? So let's jump straight into this then. So anhydrous magnesium chloride can be formed by direct reaction between its elements, all right? And then we have a nice equation here given to us. And then it says the free energy change, delta G, for this reaction varies with temperature as shown in table 2. So this will always be the case here, okay? We've got a nice data table right here. Use these data to plot a graph of free energy change against temperature on the grid opposite. Calculate the gradient of the line on your graph and hence calculate the entropy change, okay, our delta S right here, and it gives us a unit, very important here, okay, joules per Kelvin per mole. Take a note of this. We have to show our working, okay? Okay, so I don't really expect you guys to be able to plot this graph from watching a video, so unless you went to the time of having some graph paper and plotting all the data points out and everything, feel free to do that. If not, maybe printed the paper out, I don't know, but essentially all I've done, sped things up, drawn out the graph, plotted my points right here, and then drew a nice line of best fit all the way through. Okay, that's basically what you want to do in this process. Pretty simple at this point, you should be okay with plotting a graph. So when I went through, ticked all the points off, just make sure I didn't miss anything. And then, like I said, drew a line of best fit, okay? Not too complicated. Where it becomes complicated for most students, it's just working out where do I go from this? Where do I go from here? Okay, I plotted my graph, whoopity-doo, what do I do now? So this is what I'm going to explain to you guys, and you have to take this principle and apply it to all of these graphical questions when it involves Gibbs free energy change, okay? This also applies to Arrhenius graphs, okay? If you can nail this process and learn what to do, you can apply the exact same thing, literally copy-paste, to Arrhenius, and you should be completely fine, okay? So what do we have to do here? So I'm going to start with writing our equation, delta G equals delta H minus T delta S. Okay, you should be familiar with Gibbs free energy change equation. Not too complicated here, but what we have to do is we have to equate it, okay, so make it equal to the equation of a straight line, y equals mx plus c. Okay, now what do we actually have to match up these values here? So I'm going to actually look at the graph to sort of give us a little cheat here. So we've got our delta G on the y-axis and T, our temperature, on the x-axis. So then we can actually match these up, okay? Delta G is naturally going to be our y right here. And what did I say was our x was our temperature? So we know that x is our temperature right here, okay? Enthalpy change, this is going to be our C. Okay, this is getting a bit messy, so I'm going to rewrite this out actually, okay? So if we transform this to equate it to y equals mx plus c, it's going to be delta G, our y variable here, equals minus delta S. This is our m, okay? Minus delta S, so this minus right here and this delta S transforms into our m, okay, which is our gradient. Okay, and that's really important because we're going to be taking that and essentially rearranging it to make this the subject in order to calculate our nice answer right here. Okay, so minus delta S is our m times by our x, okay, which is just our temperature. And then plus C, which is just our enthalpy change, okay? This guy's not really too important right here, but you may need to use it in other questions, but in this one, pretty sure it's not too important, okay? So simple as that, guys. What we want to do, draw the line of best fit, pick 2 points on this line of best fit so we can calculate our gradient. Now, I've just picked these 2 points here. You're going to get a slightly different answer based on how you do it and which points you pick. Little piece of advice here, okay? Let's say I picked a random point here and a random point here, so that my, dodgy line. So that my gradient, obviously you want to draw a ruler, but this is just an example. My gradient is going to be really small here, okay? It's from here to here, all right? So that means that our gradient is going to be less accurate overall because we're using a shorter spread of data, okay? If you want to make it as long as possible, you don't have to do all the way along, but you want to make it as a reasonable amount so that we get a more accurate gradient, more likely to get all the marks there, okay? Just a little piece of advice there. Okay, then gradient, so our M symbol right here. Those of you that don't know how to calculate this, pay attention right here, because you can use this in every single approach, but many of you maybe did this in GCSE or did A-level maths. Feel free to skip ahead if you're really confident with this, but let's jump into our explanation here. So our gradient is just simply going to be our change in y, so this delta symbol here, change, hopefully you're familiar with that, it pops up all over the place, change in y over change in x, okay? So what you would do, you can see on the graph here, I've written change in y and change in x, okay? Now I've also put my points here for my y variable and my x variables, okay? So we're going to literally just plug that into the equation. So the equation that I use for this, maybe you guys do it differently, is going to be y2, so our y2 coordinate minus our y1 coordinate over x2 coordinate minus x1 coordinate. Okay, so all we're going to do is pick our coordinates here and plug it into our equation, okay? So I decided to put this as my y2. You can do it either way round, guys. It really doesn't matter, okay? As long as you keep the y2 variable matching our x2 variable, it's completely fine, okay? So hopefully this makes sense here. What I'm going to do, I'm going to choose this. So I'm going to do minus 600.4 as our y2, and then I'm going to minus that for our y1 coordinate here. So minus 594.6. So ultimately that's going to cancel and give us a positive value here. Well, not positive, but it's going to be plussing. So next up then, we're going to take our y2. So if this is our y2 value right here, boop, we're going to go down to the x-axis. It's just going to be 251, okay? I'm going to minus that from our x1 point. It's going to be up here, whoop, all the way down, 286, okay? Easy as that. Now, just plug this into your calculator, and you should get an answer of 0.1657, okay? Now, what is this gradient unit going to be? It's really important here, okay? So ultimately what we have is we have kilojoules per mole and we have Kelvin, okay? But that's divided because we're doing y-axis units divided by x-axis units. So ultimately then what's this going to give us? It's going to give us kilojoules per Kelvin per mole, okay? But however, we have something we have to do here is we have to pay attention to these entropy units, okay? Within the thermodynamics topic, it's really important that you do your best to remember this. I'm sort of laughing because I tell all my students this, but kilojoules per mole is the unit for our enthalpy change, getting all these words mixed up, enthalpy change and Gibbs free energy change, okay? It's always going to be kilojoules per something, per amount of substance, okay? And then entropy, this guy right here, is always, they always switch it up, but they make it joules, okay? So just try and remember that conversion that exists here, and you should be fine. Now, if you're a bit confused, I'll explain what we're doing here. Okay, whoopity-doo, we've got our gradient. How does this help us, all right? So remember that I said we have to just equate the two lines, all right? So this gradient here is our minus delta S. So what we can do here is we can say, okay then, our m equals our minus delta S. Therefore, we can rearrange this to make delta S our negative gradient, okay? Our gradient is going up here. We can make that negative, okay? So therefore, what I'm going to do is I'm going to say delta S equals our negative gradient, okay? Which equals minus 0.1657. All right, it's not that difficult. As long as you understand that principle of we can equate these two lines, whatever our m value is our gradient from the graph. Therefore, we can rearrange that to make it positive because we always want it to be positive, okay? You don't want to say minus delta S equals m. Doesn't really make sense because they are asking for the positive value here. Okay, and just like I said, this is going to be in kilojoules per Kelvin per mole. All right. Now, what we want to do here is we just want to times it by 1,000 in order to get it in joules per Kelvin per mole. Hopefully that makes sense to you guys. So I'm just going to times that by 1,000 here. And this will give us a value of minus 165.7 joules this time because we converted it per Kelvin per mole. Okay. Right, so would we just chuck that in our answer box over here? No, we would not, okay? Hopefully you guys are familiar with significant figures in AQA. So although right here in our enthalpy Gibbs free energy change column, we've got 4 sig figs right here. In the temp column, okay, we've got 3 significant figures. So in AQA, you want to be choosing the lowest significant figure of the data given. So I'm going to round it up to minus 166, well, I suppose down. And that's our final answer right there. Master this process and you should be good to go, okay? Hopefully this was helpful. If it was, drop me a like. Subscribe for future science and maths content. Really helps the channel grow. Best of luck, guys, in your exams. Peace.